Okay, so this is chapter 5 assignments. In a grocery store, you push 15.4 kg shopping cart horizontally with the force of 13.4 Newton. If the cart starts at rest, how far does it move in 2.5 seconds? Okay, so what we have here is this mass, right? Mass equal to 15.4 kg. And if you push cart horizontally with F equal to 13.4 Newton. All right, and how far? Okay, so time equal to 2.50 seconds. All right, so here what you know here is you have a force, right? And you have mass. Okay, so ask you how far it can go, distance, basically displacement. We also, what we use here is to find the displacement. Okay, so also you start at rest. So initial velocity is 0, and you know time, looking for displacement. So equation here is d equal to v naught t plus 1 half at squared. Okay, so this is a kinematic equations. All right, you need to know A. So A, we just get from Newton's law. You see here, net force, right? So you see you have a force, net force over mass, right? And in horizontal direction, so in x-axis, this is the force, only force you have. You're supposed to have a friction, but friction, we haven't talked about friction yet. Okay, so there's only force in x-axis. In y-axis, you have a weight, and also you have a normal force, but in y-axis, it is balanced. So the only force in x-axis is a force, so acceleration equal to net force in x-axis divided by mass, right? So equal to net force is 13.4 divided by mass is 15.4. And this is your acceleration. And then you plug acceleration into this equation. You see, this is 0. Initial velocity is 0. So displacement equal to half. Acceleration is 13.4, 15.4. Time is 2.50 squared. This will be the distance you traveled. All right. Second one. Driving home from school. One day you spot a ball rolling out into the street. Okay, so you see you drive and then there's a ball rolling on the street. You brake for 1.2 seconds, right? So t equal to 1.2 seconds, right? All right. Slowing your, so mass is 950 kg car from 16 meter per second to this. Okay, so you have here is initial velocity is, let's make it v naught. V naught is 16.0 meter per second. Final velocity 9 meter per second. Okay. All right. So A, what was average force exerted on your car during brake? How far? Okay, so ask you about the force. And second one is displacement, right? All right, so how to do this? You know, from Newton's law, we know force equal to ma. This only talk about horizontal direction, okay? So in order to figure out the force, average force, you have to know what is acceleration. Okay, you have mass here. What's acceleration? How to figure out acceleration? From kinematics, right? So acceleration, well, this equation, we know v equal to v naught plus at. So a equal to v minus v naught divided by a. Okay, so plug into the data. 9.50 minus 16.0 divided by time is 1.20, right? So this acceleration, and you can tell this acceleration is a negative value, which means this is a deceleration. That's why you see you drive fast and then kind of slow, right? So your acceleration is in the opposite direction. Then the braking force also in the opposite direction. Okay, so what was average force exerted on on your car. So average force on your car will be this direction, right? So force, you plug whatever here into this equation. That's the force. Okay. Then second one is how far you can travel. Okay. So then we use this equation, d equal to v naught t plus 1 half at square, right? So v naught, here's your v naught. T, you have time, right? And then a, remember a is a negative a, deceleration, right? Okay. All right, so you can plug into this equation, you can get the displacement. Next one here it is. The Vx versus time graph for a 1.8 kg object is shown in the figure. Okay, so we know m equal to 1.8 kg. In the figure below, a single force acts on the object, and the force was only has only x component. All right. So ask you, what is Fx? Okay, so what do we know here is Fx is only force, right? Equal to ma x. Then we know mass, right? But what is ax? Okay, so from kinematics, right? We know ax equal to delta v delta t, change of velocity over time, and do the limit. Okay, so I ask you about 0.5 seconds. You see, this is 0.5 seconds, right? So at this moment, velocity, this is the velocity. But what is acceleration? Well, if you have a velocity versus time graph, so this is a velocity time graph. Acceleration is slope. Okay, so you see at this point, you have a tangent line. On this curve, slope of this tangent line is your acceleration. All right, so based on this idea, what's the slope here on this graph, right? Well, it's a straight line. So slope of this of tangent to a straight line is a straight line itself. Okay, so what's the slope of this line? Slope of this line is, you see, this is x. This is a rise. Rise was run, right? So the rise over here is from 0 to 4, right? This is 1. 0 to 1 is 1. So slope is 4. Okay, so at 0.5 seconds, acceleration is 4 meter per second square. Okay, so what's the force? 4, so mass times 4, that is the force. All right, same idea, 2.0, so here, 2.0 seconds, right, here. What's the slope? What's the acceleration? You have to look at slope of this line. Slope of this line is a negative, right? You see, what's the slope? So here, run will be 2, 3 minus 1, right? So this is 2 minus 4. Okay, so basically 3 minus 1, 2 minus 4, 2. You see, you end at 2, start at 4. So this is negative 1. Okay, so this one times negative 1, that's a force. And the same idea here, what's the slope at 4 seconds, right? 4 seconds, the slope here is 0, so it'll be 0. Okay. All right, so next one. On vacation, your 1400 kg car pulls a 550 kg trailer away from a stop light with the acceleration. Okay, so this acceleration, so A equal to meter per second squared. What is the net force acted on the trailer? All right, so this is a car. So this is a car, and you have a trailer, right? And you know acceleration here is 1.85 meter per second squared. And your car mass is 1400 kg, trailer is 560 kg, all right? So what do you know here? This acceleration, right? So both of them, because they move together, So both of them have the same acceleration. All right, so if you look at this trailer in horizontal direction, well, what is direction? You have a weight and normal force. Okay, so they cancel each other. Horizontal direction, if you look at this trailer, there's only one force, which is tension. From your car to the trailer, there's only force on this trailer in the horizontal direction, and then this guy moves with acceleration A, right? So you can see net force equal to, well, so it's a tension. Then net force equal to ma. You see that? So what's the mass? Mass is 560. A is 1.85. Okay, so that's the tension. So what's the net force acting on the trailer? Well, so this is net force. What force does the trailer act on the car? Well, so this is the tension from the car to the trailer. Meanwhile, trailer through the tension, right? So through the string put on the same amount of force on the car. What is the net force acting on the car? Well, you see, this is a net force. Let's look at this car. Free body diagram on the car will be, well, so this is the force from trailer, right? Then they have a propel force, right? So move the car forward, and then you have mg, you have normal force. But you know this car move with acceleration 1.85 towards the right, right? So you know based on Newton's law, net force equal to ma. Okay, and mass here is 1400, A here is 1.85. Okay, so this will be the net force on the car. Okay, all right, next one. Next one is a force of magnitude. So this is a force, 7.5 Newton push 3 boxes with the mass M1, M2, and 3. Okay, find the magnitude of the contact force between 1, 2, and 2 and 3. All right, so how to solve this kind of problem? I discussed this in class, right? So we can consider this whole thing as one unit. Okay, so in horizontal direction, there's only one force, so this is a force. So the whole group will, you see, net force equal to ma. See, net force equal to ma. Okay, so A equal to net force over m, right? So net force in this whole group is 7.5. Mass for the whole group is 1.30 plus 3.20 plus 4.90. Okay, so this is total mass. Consider this as a whole group. Okay, so you figure out acceleration. All right, next step. Ask you what's the contact force between 1 and 2. You see, this is 1 and 2. 1 and 2, right? Then what do we do here is we take 1 out of the environment, right? So this is 1.3 kg. Look at this 1. We do a free body diagram. You see, this is 7.50 Newton. And then you see 1 contact with 2. So 1 push on 2. 2 push back on 1. Okay, so there is a force from 2 on 1, and in opposite direction. Okay, so for 1, there's only one force. This is only, you see you have a force here, that's force, right? So you only have force in the horizontal direction. To make the acceleration, so vertical one, you have mg, you have normal force. And the motion status is this object move with this direction with this acceleration. Okay, so what we have here is net force in the force of object 1 equal to 7.5 minus 1 F12. Okay, so that's net force in horizontal direction equal to ma, right? M here is 1.30. A here is this value. Because everybody here, the whole group here move with the same acceleration. Okay, so you get it from here. Okay, so you get acceleration, and then you have this force, right? So looking for F12. Okay, so from this equation, you can figure out F12. All right. So same for the force between 2 and 3, right? So you can, in this case, you just look at object 3, 4.90 kg, right? Well, free body diagram, there is the force from 2 on 3, on 3 from 2. Okay, so that's only force in horizontal direction on object 3. Okay, so also you have mg and you have normal force, right? All right, so this object move with A. All right, you can tell net force equal to F32 equal to MA, right? So M here is 4.90. A, same A here. So this guy, whatever you calculate A, plug in. That's the force between 2 and 3. Okay. So so let's move to the next one. Next one is an object acts on by 3 forces move with constant velocity. Okay. One force act on the object is in the positive x direction and has okay, so object 6.5 Newton, and also we know V equal to constant. Okay. The second force has a magnitude 4.4 Newton and point in the negative y direction. Okay, 4.4 Newton. Find the direction and magnitude of the third force acting on the object. Okay, so this is F1, F2, and you have force, right? So F3. Okay, we don't know F3, right? You can tell, gut feeling, you know F3 must be in this direction, right? So F3. And so you have 3 forces acting on this object, so that objects move with constant velocity. What does it mean? If velocity is constant, then A is 0. If A is 0, which means net force is 0. Okay, so if A is 0, then net force is 0. Okay, so net force equal to F1 plus F2 plus F3 is 0, right? Okay. Well, we use the components method, right? So which means F1x plus F2x plus F3x is 0. Okay. So this is the net force x component. Then net force y component is F1y plus F2y plus F3y is 0. Okay, so we can figure out, well, from those two equations, because we know F1 and F2, right? So let me write here. Okay, so you see the first equation. What is F1x? Okay, so F1x, you see this is F1, right? F1 is x component, only have x component. So from first equation, we know 6.5, this is F1x. F2x is 0. You see F2 is on the y-axis, right? So plus 0 plus F3x is 0. So from this equation, we know F3x equal to negative 6.5. And the same idea, from this equation, right? F1y is 0. This is F1. Okay, so 0 plus F2y. Okay, this is F2. So negative 4.4 is in the negative direction. Plus F3y is 0. This tells us that F3y equal to 4.4. Move this one to the other equation. Okay, so we know that F3y is 4.4, right? This and F3x is negative 6.5. Okay, so this is negative 6.5. This is 4.4. All right, so now what is F3, right? F3 equal to F3x squared plus F3y squared. Direction, angle theta equal to inverse tangent of F3y, F3x. F3y is, okay, F3y is 4.4, F3x negative 6.5, okay. So you get a negative angle here. However, this is in the second quadrant, so whatever angle here you get plus 180. That's angle. Okay. All right. Next one. Next one tells you that. Oh, by the way, I have to see that this problem. This one asks you about the what was average force acting on your car. Whatever you get here is negative, but you just give the average force acting on a car. You put the magnitude, so which is give you a positive value. Okay. All right. Next one, number 8. As part of a physics experiment, you stand on a bathroom scale in an elevator though your normal weight, right? So normal weight is 610 Newton. The scale at the moment reads 730. Okay, so normal force, that's a scale 730 Newton, right? Is the acceleration of the elevator upward or downwards? Okay, we will see. Calculate the magnitude of the elevator's acceleration. Okay, so here, if you say this is you, right? You step on a scale. Okay, so if you do a freeboard diagram on you, two forces, right? So you have mg is your weight, right? So this is a 610 Newton. And then you have a normal force. It's a normal force. That's what you read from the scale. Normal force equal to 730 Newton. Okay, so that is you only have two forces. So we can calculate net force equal to normal force minus weight, right? Equal to 730 minus 610, right? And based on Newton's law, net force is ma. Okay, so left side is 730 minus, so left side is 20. What's the mass? Mass is weight over g, right? So if you know your weight, right, mass equal to g, right? So equal to 610 divided by 9.81. Okay, so let's plug in directly. So mass is 610, 9.81 A. Okay, because normal force is bigger than weight, so acceleration will be upward, right? And what's the value? Just solve this equation. You got the value. Number 9. 23 kg suitcase. So M equal to 23 kg suitcase is pulled with constant speed. Okay, here important, constant speed by handle at an angle. Okay, so 2.5 above the is pulled, right? Pulled. Pulled is this way, right? So this is pulled. And then 25 degree angle above the horizontal. If the normal force acted on the suitcase is 180, okay, so this is normal force. Then, what is the force applied to the handle? All right, so let's looking for F. Okay, so what you do here is you have to do freeboard diagram, right, on this object. How many forces are there on this object? You have weight, normal force, applied force. Okay, so that's it. And constant speed, right? Which means you move with a constant speed. A is 0, right? Constant speed, which means A is 0, all right? So let's make a x-axis here, y-axis here. So if you ask about the applied force, right? Okay, let me see, 23 kg, so this is 23 kg, okay, normal force, right? Okay, so what we have here is this. In vertical direction, you have net force equal to 0, right? In vertical direction, so Fy equal to, you see, vertical direction, this is 25 degree, right? In vertical direction, you have normal force up, and then you have a component from here, so plus F sine 25 degree, and then minus mg is 0, right? Okay, So F sine 25 degree equal to mg minus normal force. So what's mg? mg is 23, right? 23, 9.81 minus normal force is known, 180. Okay? And now from this equation, right, you can figure out what is your force. Apply force, right? Apply force equal to 23, 9.81 minus 180 divided by sine 25. Okay, so that's your force. One more thing here is why you can move with constant speed. Well, in the horizontal direction, you have friction. Actually, yeah. If no friction, you definitely cannot move with constant speed, which means in horizontal direction you have friction. Okay, so that's why they didn't ask you about the horizontal direction. All right, next one. Figure below shows the normal force N experienced by a rider of weight mg on a Ferris wheel as a function of time. Okay, so this is a Ferris wheel. You see, Ferris wheel. So you sit here, right? You sit here, you sit here, you sit here, right? And this guy doing this kind of a circular motion, right? So circular motion. Okay, so you round this way, going this way. All right, so if you look at the normal force, when you are here, we know circular motion, right? So when you are on top, this is your net force. When you are here, this is a net force. When you are here, this is net force. So net force always point to the center. All right. So net force equal to, well, the change here is A, right? A is normal force, right? In terms of mg, right? So normal force here is 1.20 mg. Normal force equal to mg. Normal force equal to mg. Normal force equal to 0.80 mg. All right. So A, at what time ABCD is the rider accelerating upward? Okay, so if you look at the rider, so this is a rider, right? At any given moment, you have weight and normal force. You also have upward acceleration. Normal force must be bigger than weight, right? You see here, normal force bigger than weight. This here, normal force smaller than weight. So only A, normal force bigger than the weight, right? So you have upward acceleration. B, what is the magnitude of the maximum acceleration experienced by the rider? Okay, so what's the maximum acceleration? Okay, so net force equal to, you look at difference between normal force and mg, right? And then equal to ma. You see that? You see, so this is a 1 point for here. Difference here is 1.20 mg minus mg equal to ma. You see? Then what is A? So at point A, acceleration equal to mass cancelled, right? 1.2 g minus g, actually 0.2 g divided by, that's it, right? Mass cancelled it, 0.2 g. Okay, so that is at position A. B and C, because normal force equal to the weight, no acceleration. D, what's acceleration D? Well, net force, right, equal to, you see mg bigger than normal force minus normal force equal to ma, right? So A equal to, you see, cancel, right? So is G minus, this is 0.8 G, okay? So this equal to 0.2 G, right? So actually, here you get the same acceleration, but this acceleration is point down. Okay, so Ferris wheel, and this D corresponding to you are on top, and A corresponding to you are on the bottom. Okay, acceleration, right? It's the same actually. Okay, but the direction is different. So what is the magnitude of the maximum acceleration? Maximum acceleration is 0.2 g, and here is the same, 0.2 g. Okay, so 0.2 times 9.81. So that is acceleration. All right, number 11. Find the normal force exerted on a 2.9 kg. So M equal 2.9 kg book resting on a surface inclined at 36 degree above the horizontal. Okay, so here's the book. Okay, so book M. Find the normal force. All right. Stay at rest, right? So if you do a free body diagram, that is mg, right? Normal force. Okay. What else? If this guy stays at rest, you must have friction, and this is static friction. Okay. So find the normal force. So what's normal force? In this case, let's build, this is x-axis, this is y-axis, right? Okay, so net force in y-axis equal to, okay, so we have to break down this mg into horizontal and vertical, okay? So this is mg cosine 36. This is mg sine 36, okay? All right, so in the vertical direction, in the y-axis is normal force minus mg cosine 36. And that's all the force in y direction. This equal to ma. A is 0, so this equals 0. So n equal to mg cosine 36 degree. And then m equal 2.9, 9.81, and then cosine 36. Okay, so that is answer. And second, if the angle of the incline is reduced, okay, is reduced, right? Smaller, right? Do you expect the normal force increase, decrease, or stay the same? Okay, so normal force, this is the equation, right? So angle became smaller. Okay, so this guy became smaller. If we look at this is the angle, right? So cosine angle. This is the cosine angle. So angle became smaller, cosine increase. You see angle here, and the angle here, cosine increase. Okay, so this increase, normal force increase. When angle equal to 0, right? So this is 0 angle. Then the normal force equal to mg cosine 0. Okay, so if angle is 0, cosine 0 is 1, so equal to mg. Okay, indeed, on a flat surface, normal force equal to the weight. Okay, a gardener, number 12, a gardener mows a lawn with an old-fashioned push mower. The handle of the mower makes an angle 32 degree with the surface of the mower. Okay, so here is mower, right? So push, which means you apply force this way. And then this is 32 degree. If 68 force, okay, so F here is 68 Newton, is applied along the handle of 17 kg. M equal to 17 kg. More, what is the normal force exerted by the lawn on the mower? Okay, so ask you, this is long on the molar, right? So basically, if you look at the free body diagram on this molar, all right, so you have weight, mg, normal force, and then you have a force. Okay, so F equal to 68 Newton, 32. Looking for normal force. All right, so what's normal force? All right, so this is the x-axis, this is the y-axis. Okay, so let's look at net force in y-axis equal to, you see, this guy have components in y-axis, right? So This is down direction, right? Okay, so normal force positive minus 68 sine 32 minus mg. Okay, so that's all the forces on the y direction. This is equal to 0. MAA is 0, right? So normal force equal to 68 sine 32 plus mg. M is 17 G 9.81. Okay, so that's normal force. Well, this makes calculation, that's normal force. B, if the angle between the surface of the lawn and the handle of the mower is increased. So basically this angle, right? So 32, right? So now increase. Okay, make this angle, right? So this increased. And then does the normal force increase, decrease, or stay the same? All right, so this equation basically, this equation, right? So normal force, this equation. Normal force equal to 68 sine theta, right? Plus mg. Theta increase, if theta increase, sine theta increase, you see, this is sine, right? Theta, and this is sine theta. Okay, so this is 90. So you see angle increase, right? Increase. Okay. So increase, you go this way, right? So theta 32 here, right? Then increase, you see, sine theta increase. All right. Okay. So, okay. So this is increase, right? So it's increase. Okay. So this increase. All right. So that's all for this chapter.